All right, section 1.6. So in 1.6, we're looking at perpendicular lines and the different relationships that might occur with those lines. And then once again, like we're just trying to get to the spot where we're like providing justification for certain steps inside of our proofs. So our homework assignment is, if I jump straight to that, is that we see that for 1.6, trying to get the right spot there. Let's see, there we go. So for 1.6, what we see is we start off and like we've got like they're starting to really introduce this idea that we have a given thing and we're trying to get to a certain proof of like what we want to show and like how do we justify each step. And so what I really want you to take away from this section is just getting comfortable with what justifies a certain statement. So if we start off and we say we have a given, then how can we say that they're congruent? Like which postulate gives us that? Which theorem gives us that? And being able to go through and start realizing and making those connections between those justifications. And that's kind of like the key thing. So as we continue to grow towards writing proofs, we get comfortable with like how we can use and when these can be applied. Um, if you're like, I don't understand why that isn't like why that applies right there, reach out. Like, I mean, it can be for some people, it might be like totally intuitive. Like you're just like, oh, that makes perfect sense. This postulate says this ties in right there. No problem. For others, it might be like, it's like I'm trying to see how it connects, how it starts from the top and goes to the bottom. So just reach out with those questions so I can help you. Otherwise, your job for this is like, let's just talk about kind of breaking it down. So vertical line is a line, I'm sorry. Informally, a vertical line is one that extends up and down like a flagpole. On the other hand, a line that extends left is called horizontal. So that's pretty straightforward. So we say line L is vertical and line J is horizontal. Perpendicular lines are when those two lines that we just talked about form to create congruent adjacent angles. So in this case right here, what ends up happening is that we have line M and line P. They are perpendicular lines. They form a 90-degree angle. So that way we have adjacent angles. So this angle over here would be adjacent to that angle over there because of the 180 rule. And that with supplementary lines is that these two angles, supplementary angles, these two angles add up to 180 degrees. So that has to be 90, then that's 90. Or we could go vertically and we could say that this angle up here is 90, so that angle down there is 90, and vice versa. We can keep moving our way around. So that's the idea of like using perpendicular lines to like describe these angle relationships. If two lines, so we have a theorem that comes out of this that we can then use like as we move forward. So if two lines are perpendicular, then they meet to form right angles. So in this case right here, if we come across a problem that says these two angles are perpendicular, then we can then justify and move forward to say that their angles are perpendicular, or right angles, excuse me. So right angle, right angle, right angle, right angle, based upon this idea. So we could kind of work our way around and use that as we move forward. Here's how we get there. So we start off by saying that they are perpendicular. That's our given. Because they're perpendicular, we can then state that those perpendicular lines create congruent angles, and that's by the definition of adjacent angles. From there, we can say that the measure, sorry about that being out of place, the measure of angle C is equal to the measure of angle CEB. So, right, if we go back to our image, so the measure of angle, let's see, AEC and CEB. So the measure of angle AEC and CEB are congruent because if the two angles are congruent, then the measures are equal. And then we move forward. Sorry about this being all tore up like that. I'm going to go and run with this video and worry about correcting it next time. Angle AEB is a straight angle. So we go back and look at AEB. So AEB is a straight angle. That means it's 180 degrees. And so we justify that by saying it's a straight angle, then we know it's a measure of 180 degrees. From there, we can then start working through our angle addition, and we can start looking at angle AEC and CEB. So I'm just going back so we can see that. So AEC and CEB, so we're saying if we add those two together, they are going to add up to that scenario. Then at that point, we can start substituting. So we can say AEB and CEB or AEC and AEC add up to equal 180. So since they're equal, then we can like substitute and then start building our way up. And then we can say by the division property that AEC is 90. And since we can say that it's 90, then we can say it's a right angle. And we can justify that we're getting to this spot where what we're trying to prove was that angle AEC is a right angle, because we're using through and walking through this like scenario. So it's tricky, because what ends up happening for you is you get to the spot where you're like, that just seems so intuitive. Why do I need to say that? Why do I need to prove that? And that's where the tricky part comes into play. So practicing these with your answer key and with the proof and trying to like really try to work your way through is going to be kind of key to get you ready for the test. All right, I'm going to stop right there and I'll start a new video for relations.